Hey everyone, how's it going? Hello. So this is a DPIN talk, but on the Cosmos side of cosmolocalism. So it's JSON, easy access JSON as smart contracts, so that Raspberry Pi people and other command line interface calls, as well as we'll see even front-end calls, can quickly access JSON using an RPC. And then tomorrow we'll be doing a workshop. Whoever's interested in this topic, we'll be doing a workshop on finalizing the standard and also drafting a version of it that we'll publish on one of the chains. And then on Friday, when we do the Cheerbot workshop with Switzerland and VDAO, we'll be using that JSON to do our REST calls. Yeah, it looks muted, yeah. Okay. Yeah, so NFTs. NFTs, here are the really popular NFT collections, some of them. And if we see, this token URI is used by pretty much all of them. CryptoPunks doesn't use it, but it has hard-coded on-chain storage. It's also one of the first. Autoglyphs is another exception, but for the most part, all of them use token URI. So keep that in mind, what token URI is. And then there's also contract URI. What about that one? That one's not used as much, but it is another way to store JSON with NFTs. And then down here, okay, yeah, all right, that's it for that one. Okay, so this is ERC-7827, and so this ERC, this is well, let me take a quick pause because I've said some stuff that is quite technical. Who here knows what an NFT is? Okay, good chunk of people. Okay, and then so who knows what ERC-721 is? Okay, a good chunk of people. Would anyone in the audience like to say what 721 is? Anyone? Yeah? All right.
It's the Ethereum standard for NFTs, right?
Yeah, and it's used on a lot of other chains as well. It is pretty much, it made NFTs happen. But what's really interesting here is that so this token URI here, and again, all of the, most of the projects that have made good money, that have put NFTs in the popular, in pop culture, are, they all use, see, all of them use this optional standard in ERC-721. And what this optional standard is, it's the metadata JSON schema. So if you want to look up your Bored Ape picture, your expensive JPEG, the way you do that is you go to this optional aspect of NFTs, and then you find the image here, and then it'll point to wherever the Bored Apes are at, which for most of the popular collections, they are stored not on-chain, they're stored off-chain using IPFS, like Milady. So my other chat left, but anyway, I guess I'll say it. I'll say it. I don't know where I put my other chat about this, but with the AI. But so William, I think it's William who is the lead author. Well, let's just see, make sure I'm right with the authors of this standard. Yeah, William. Yeah, there's a really great Ethereum cat herders conversation with him. He explains that his purpose for NFTs, it was logistics, it was physical transportation, certificates of authenticity. If you've read or if you know about Mika, that's a fundamental concept in Mika, that what these NFTs are is a certificate of authenticity. And that's why the JSON aspect of this is optional. So the standard that makes NFTs what they are, it's the NFT standard, the most valuable aspect of them in commerce so far has been the metadata, which is actually optional for them. So I'm going to pause there and ask the audience, has anyone, what are your thoughts on that? If anyone has any thoughts, raise your hand if you've got any thoughts.
I mean, yeah, if it's not on chain and the thing that you're linking to goes down, then your image of your NFT is gone. So sad.
That is sad. What about the fact that NFTs were not designed for what they're being used for? That's what I'm highlighting here, that they were designed for logistics. The JSON metadata is optional, and yet that is where most of the value NFTs have found market fit.
Yeah, also the format of the JSON that the metadata links to, it's not standardized itself. It's basically, I guess, just it happened to become like what it is, and then OpenSea, the biggest NFT marketplace, was like, this is how we want the data, so everyone followed that. So there's definitely like room for improvement and to have like standardized schemas that are not just the biggest platforms saying this is how it is, but maybe it could be another ERC.
Yeah, yeah. And let's look. Here's OpenSea's standard, and yeah, they have determined it. That contract. The reason I looked up the contract URI one to see if it was actually if it had found popularity is because here it is. This is OpenSea and it's so this standard. If we look at this standard, it's in draft. So where all the value is in NFTs, the one standard that's directly addressing the URI, and yes, it's not the token URI, but the contract URI, it's in draft. So here we go, yeah. So here's what they've suggested. It is the de facto standard. Oh, here it is. Here's the talk with the AI. Yeah, okay, so yeah, Willie made it. Problem, yeah, obviously fungibility, that was a big issue. Yeah, right here. Was he working on certificates of authenticity? Yeah, he was. Here's another interview that the AI points to. These were the concerns. Enterprise, legal property rights. So as a legal engineer, that's really interesting. Tokens. AI uses tokens as well. Logistics and certificate of authenticity use case was a core origin story. So yeah, so NFTs, wildly successful, but not the original intent. Okay. So now on to this standard. So what I'm doing with this standard is I'm JSON, and I'll give other reasons why I believe JSON is very valuable, not just that NFTs themselves, tokens themselves, the value, at least product market fit, has been the JSON. The metadata is JSON, just to clarify that. The metadata is the data type. JSON. So let's have that instead of token URI, I mean, that's fine for tokens, but we know how valuable it is, so why don't we also have it as an offering, an ERC? So it's not an ERP, we're not changing the blockchain, we're just having a template that people can copy paste. We have the JSON object. Certain JSON objects, lots of JSON objects shouldn't take this, but a JSON object that is a smart contract. That object is so valuable that it gets to be its own smart contract, so it gets its own address. So that's the core point of this standard. And so, yeah, the rest of the talk, I'll give reasons why I think that's so valuable on top of the NFT part. Yeah, sure.
Thanks. You mentioned its own contract address, so are you designing this so that it's a separate contract from the main NFT one, or just backwards compatible, I guess, with existing ones so that you can add that layer on top?
Yeah, so this is not an NFT. So enter data. I think one of the slides I'll share. I'm recognizing that the intranet of an EVM system, tokens are great as interdata. Looking at how the internet operates, the vast majority of interdata is JSON. Vast majority of it. So this is a smart contract as JSON for interdata with the entire internet. And then tokens are still definitely very useful within the intranet. And a solution I'm doing, taking inspiration from von Neumann, is that this side of it is the data, and the NFT side of it are the instructions. And the NFT is a HTML object that then calls this JSON as a smart contract. So they're two smart contracts. There's NFTs. So it's not within the NFT. I mean, token URI is fine. I'm not. It's fine. Actually, it's not just fine. It's base 64. I'm doing base 64 token URI to have the instructions directly on chain, and then it calls this as which then the whole internet can call this as well. So this the JSON I want exposed for the entire internet is this smart contract.
So indeed, you'd have one 721 contract and one 7827 contract.
Yeah.
Separately by design, at least. Yeah.
Yep. And it's 1155 in the example, but we don't need to get into the weeds. Okay. So yeah. So for the standard that we're doing, I'm hoping that we can, as an artifact for Switzerland, especially because the first draft of this was an artifact for Megazoo, is just the names of the methods. So I'm pretty certain the names for the methods for the read-write using an RPC are good, but especially the read for the on-chain read, because that isn't a public good, it costs. I'm hoping to have a discussion about what method names should be for that, and that's what we're going to be doing tomorrow, in addition to drafting one that we can use at least as an RPC. So yeah, so this is the standard for that. I'm going to take a pause real quick and get into what is an RPC. So can anyone here explain what an RPC is, and maybe gateways? Yeah, would you like to? You taught me the more generalized concepts, so I would love it if you could explain to everyone RPCs and gateways.
So what an RPC does, it's called remote procedure call, and it's like basically a server, or in this case the EVM, can specify like endpoints that either return data or you can write data to, and these RPCs basically access these endpoints, and you can send data, you can receive data. And in the case of a smart contract function like the JSON you defined, you would basically tell the access node of the Ethereum of the EVM to return the data that is behind this JSON RPC. Technically it's called ETH call, and then in there as a parameter you say call this contract with this function, and then it returns the data of that smart contract.
And then what's a gateway?
the gateway would be your node that you're accessing to call the RPC, right?
Yes, yes, and I guess what I'm getting at here is the difference between that and a single access server. So IPFS, that's a gateway. So there are other gateways, but that's how distributed ledger technology operates. It has gateways rather than this is the single server you get. That to me is a critical difference between Web 2 and Web 3 is that. So RPC is a very important one, and we see here Infura is a very important company that's offering RPCs. If we can use multiple RPCs, we can run our own RPC. So as opposed to a traditional provider where the database that they're offering, because it's closed source. So if we transition to RPCs and other gateways like IPFS on the internet as a whole, that's a huge win. Huge win. So essentially, this is a little small to see. I've got other slides. Original image. What does that do? Okay, yeah, so this is, if we get normal REST developers to have as easy of a time calling JSON as they do in the Web 2 environment with an RPC, that's a really big win. That's what I'm suggesting at the core of this of this standard. As we move Ethereum and distributed ledger forward, period. That's not necessary for this to be value add, but that's the big picture, and I'll share a little bit more slides on that. So, but yeah, I mean, this is with the standard. So the standard has JSON as the method name, so it's as close to await response JSON as possible. I think this is the standard's lowercase to be as close as possible. There's a call, so it's not. I mean, yeah, it has more complexity here. The ABI, we can abstract away the ABI if we have it a very set ABI, and that's why this standard is supposed to be as unopinionated as possible. So not only is it JSON, but as JSON, it's really just these names, and well, I'll get into the standard more detail instead of right now. So, but I think we can abstract away the ABI, but maybe not. Maybe the standard is a subset of a smart contract with other methods, and that's not doable. But that would, I mean, we can do both kinds, right? It would definitely make it a lot easier if we just have that ABI, say in the Web3 library or what have you. And so a normal REST developer doesn't care about Web3 at all, and they just want to have easy access JSON that's there all the time. They don't even know what ABI is. And the big thing that they have to know is the difference between a URL, the HTTPS, and using the aux address instead. So yeah, we can make this about half as long, and the main teaching thing is just choose the aux address over for the contract for that JSON. The JSON gets its own aux address over the domain name that could change. So we'll also have way less link rot. So all right. So here's a early version of it, what it looks like. So RPCs are public, this ether scan, or RB scan in this case, this is a public good. Yeah, it's free to read this. AWS it would cost something, but in this ecosystem, because we pay to write, we also though get all this read for free. It's a trusted environment, it's a particular RPC, but we can use a few RPCs that offer it as a public good to compare and make sure that they're the same. And so yeah, really this is just a string. So you know, this is an early version again, different method names and such. And I've changed the way that this is called. And then we can look at the code. I'm not a Solidity developer, so I didn't write it in a traditional way, which again, the standard is just naming the method. It's not this particular version of it. It's just when people call the method, they expect a certain response, and that's all the standard should say. Okay, yeah, what on this, what am I missing in the live stream for the screen? Okay. Yeah. It's okay, good, okay. Thanks, okay. Yeah, so this is what it looks like, the early version of it. I don't want to stick on it too much again because it's a really early version and I'm not a Solidity developer. And I'm hoping what we publish, since the Viper people are here, and we're doing DPIN, so we're doing Raspberry Pis that will be using Python code anyway, that the version that we deploy for Friday will be, yeah, in Viper rather than Solidity. The core thing about this is that it uses, yeah, this here. Okay, so the other part of this is the value version control. So one of the positives of having the smart contract just be the JSON, rather than the JSON is a URI for metadata within a token. But yeah, the actual inner data is just JSON. So one JSON object is one smart contract address, is this value version control. So with this, it's a struct. So basically, for each key value pair, the value is actually an array. And then when the value is overwritten, then that's actually just adding appending to the array. And so the easy call, that's just the JSON call, is the last in, first out, so LIFO of the array. So a simple call, it's just that. It's just like you would when you overwrite JSON anyway. But since it's on chain and it's about the JSON we want to have with this having its own smart contract address that takes up a lot of real estate, is the kind of JSON we also want to look at the changes of the value, the immutability of it. So that's the point of on-chain stuff. So we could definitely have a standard after this standard that removes value version control, would have a very low footprint, and it would just be the string and doesn't care about the history, and we could look at transaction. But again, another thing we're doing here is for REST developers. So traditional REST developers, the method, they get an array, then they can look at the history. And what I found is stuff that, like promises, it works a lot like promises. So if there's a particular JSON in there that I put as a request, and then I want some other machine on the EVM to fulfill that, it overwrites it, and then all I have to do is a quick check on the array size, and if it's changed from 0 to 1, then I know that there's been a response, and then I can look at that response. So again, I'm trying to have this as just a interdata pattern, and then people can use that pattern for various opinionated use cases. So, yeah, a little bit more about that. Let me pause there. What are people's thoughts, especially things about like link rot, of the values, the version value control, and then also maybe being critical, because how much bandwidth and is this going to take up? You know, having JSON as its own JSON object as its own smart contract. Like, why hasn't this been done before? Maybe for technical reasons, it's going to, like CryptoKitties crashed Ethereum because it took up so much juice. It was kind of exciting, that crash, because the price went up, so it wasn't a full crash. It was just regulated by things being overly expensive. So it was fascinating to see a world computer, how it gets all clogged up compared to a traditional computer. But yeah, so I'll pause there. Are there any comments from people?
I mean, I think I really like the idea of, for one thing, having all that all on chain for the reasons you mentioned before, right? And the versioning also. One thing I'm not sure I'm clear on right now is that typically for NFTs or 1155, each token ID has its own set of metadata. And I'm not clear how the current spec enables that because the JSON doesn't take any input, right? So what metadata does it return for which token?
Yes, remember the standard is not a token standard. It's the least opinionated interdata possible. It's just JSON. And so, yeah, I'll show next that the token, it uses base 64 as an instructions, which is a HTML object that has JavaScript in it. That JavaScript then gets the client to call this JSON object, and then it populates that token. So the token identity is still within the token standard.
I guess, I mean, maybe you'll get to it a bit later. I'm trying to understand how that would fit like an actual implementation with a 71. Would that mean each token have its own 7828, I think, was the ERC?
7827, but yeah, whatever.
I'm not clear on that, but
Yeah, so it's two smart contracts. So that does bring up von Neumann. It's two smart contracts separate. And von Neumann architecture, all these computers running on, they're fully physically separated. So in this Cosmo environment, they're separated because they're totally different smart contracts. And then we're getting the client to do the work of calling the just the RPC, but yeah, calling, because it's on the client side, the RPC for this for the smart contract that's just JSON. So that means that the token can prioritize being the instruction set, and then the JSON is like a config file, but it also exposes the JSON for things like a Raspberry Pi, that it can be just a simple REST call, and it doesn't interact with the token. So that's why it's a way less opinionated interdata, because things that can't interdata with the token can interdata with JSON. Basically everything can do a REST JSON call.
okay, thanks.
Yeah, so here's a practical example. So this is the JSON state. That's the name of it, but it's the standard ERC-7827. And this UX NFT. So this is an NFT that is a website. So a DOM, iframe, that's the most NFTs can be, as long as NFTs are staying in the browser. That's the most dynamic and potentially even quasi-agentic, with if we include an AI server behind it, that an NFT can be, as long as NFTs stay in the browsers. So far that's what I've seen. So one NFT equals one document object model. That's not a standard I'm sharing now, but that is the philosophy behind this NFT pattern I'm doing. And then so here it is. Here's the NFT in OpenSea. It's part of a collection, front-end test collection. So it's number 23 in front-end test collection. And then, so OpenSea doesn't accept any same origin iframes. Now, this is a static thing. It's base 64, so we can have OpenSea do that job, where certain NFTs, they're static, and so we can go, okay, yeah, we'll offer the same origin. We know that this is safe. But right now, OpenSea doesn't make those distinctions. However, it still has to host the website, because it needs to host the website and then on the OpenSea thing, cut off same origin, because otherwise there's no host for the website. So this is a way to have websites, if we use NFTs as document object models, a way to get all these NFT providers to host the website as a public good. So here's how you get to it. You just go into inspect, and then within this, the JSON. Yeah, but we still have to have an API in there. This here, this is the, I'm not going to get into it, but this is the hierarchical script database. So there's like a kernel I use instead of a framework, so that these NFTs as websites, even though they can just do base64, so very small footprint, actually do have quite a bit of functionalities. So feel free to jump in there and kind of delve into that. And let me do initialize. So I do initialize, see it says, oh, sorry, you're on the wrong chain. So then I go to the right chain. And there we go, okay, then I get all the info, because I got that from the RPC. So I'll pause there for your question, if you have more questions on that patterning. Okay. Well, let me show you the Raspberry Pi. So these are the things we're going to be building on Friday, these cheerbots. So the ones we're building on Friday in collaboration with VDAO is more about agriculture. So we'll have plants, kind of like chia pets, inspired at least, and herbs. So, but these cheerbots, they've got a moisture sensor that they'll have included in them. And but here's, let's see, yeah. So here's the bots doing, asking for tips. So tipping, sending funds, all that, that's great on Ethereum. And then they look on chain. And the thing I want to show, highlight here, is that the Node.js interface here, the REPL interface, is very similar to the console that the NFT is actually running. So one of the things we're going to be focusing on Friday is people getting used to command line interfaces, people getting used to SSHing into things. And so that's part of the overall picture here. Just so you know. And then just a thought on MCPs. So MCPs, I've been working a bit with Nani.oo, that DAO AI manager, and it's a command line interface. And so I've gotten it to create basically MCPs. It's stored as JSON that gives basically a definition, a very concise definition, and then I can go into different states for that AI, ask it to look at that JSON, and then it can create a whole basically bash shell environment on top of the existing bash shell environment, which in Nani's case is our methods or our Ethereum methods, and so we can do these Ethereum methods with this basic, it's MCP, and in effect, if you want to delve into that more, if you just go to ape.mirror.xyz and that's here, it's the latest article I've written, prompt engineering. So what I'm saying, critical to this, that's JSON, that an AI that is enclosed in an Ethereum environment. If you can read just a straight up JSON object, that AI can do a lot with that, because it can then construct entire environments from those JSON objects. And Nani is an example of an AI that can only ask the chains that it has access to the methods on, and otherwise it can't interact with the rest of the world, which we're thinking about AI agency and restricting its range of motion so it doesn't go over motion, which could mean in humans dying or something like that. We can use methods on chain to give it a really constrained range of motion. And again, Nani is one of those NFT projects that's pioneering this composite of AI and blockchain. So here's if you want to do and no one has actually gotten the Megazoo riddle yet. So if I need to put it back up, but if you want to do the Mega Zoo riddle, first winner gets a prize. Okay, so this is going over what I was saying earlier, but this is these slides I did during Mega Zoo. So, we've mainly been focusing on part one in this talk, and then part two we'll be doing it a bit in Friday, and I've been referencing it. So this is the big picture. I don't know if people know about crossing the chasm, but to me, what we really, we're stuck in the chasm right now to the early majority of all developers out there. This isn't a little, I mean, how many developers are using these systems? It's still a very small portion of developers. So yeah, for me, it's these collectible toy robots that are going to be using really simple RPC calls to spread cheer. Is a way to basically make it nice and sugary that the majority gets invested to some extent. And so, yeah, so we were talking on this before about how important RPCs are. But yeah, so basically what I think our internet experience right now is the top experience. So when we go to something like, not to pick on Facebook, but we go to Facebook, that's it. We just interact with Facebook server, and if we don't like the way they're sharing our years and years of family and friends photos and memories and such, too bad. That's the state bakery. However, if we had that built out on a DLT, we would have so many different providers of the beautiful baguettes. So if we look at the RPC environment, it's pretty important. This was, I think, GG22, the last Gitcoin round, an example of someone that was an indie RPC provider. And then here's JSON. So here's how as an internet data, JSON is way more in use. XML used to be the main standard, but JSON, because it's a subset of JavaScript and easy to read, human legible, it's now the dominant one. ML, markup language, that was invented by a legal engineer. It's redline drafting in law. That's Charles Goldfarb. He took inspiration, made HTML, and so he's considered the grandfather of the internet. Just as an aside, shilling legal engineering as while I'm here as Switzerland as a legal engineering co-curator. So here's something that was really interesting. When we were at MegaZoo, we realized that these blockchain explorers are not parsing JSON correctly. So the Ninja team was there at MegaZoo, so they were able to fix it. And so now you should be able to go to ABI Ninja and use that. But that was one of the reasons I made that NFT there while I was at MegaZoo, the one I just shared earlier, was so that I had a way to read write JSON and have it properly parsed. So that's something to consider. We're very sophisticated with blockchain explorers, but we move so fast into our own interdata that we actually didn't get the very, very basics. Still haven't, I don't know if Ethersky, I haven't looked at it, actually parses a JSON string appropriately when it's being written. This is about what we were talking about, OpenSea and all that. Okay, so yeah, so look, most developers, the vast majority of developers are there. So if we want to meet them where they're at, the pragmatists of the developer world, we'd give them JSON. That's what the rest developers want. That's what they know how to do. But though high priority JSON, the JSON that, the config files, the dot files, the marionette control. Look at how many REST developers have no RPC experience. So this to me is the slide. Or SOAP devs. But I think we can do much better as we explain this technology. Just do a JSON call like you're used to in REST and do it with this RPC system. We can teach that to developers in 5-10 minutes. And then this we can really change this. They might not adopt it, they might not use it in their day-to-day builds, but they should have some experience with RPCs. So this is, more of what I was saying before. The REST call is very easy. our RPC calls, now that we've got a method that's just straight up JSON, it's much easier, but we can definitely simplify it with this standard. And then this is going into that NFT we were just talking about. And then this, is the Cosmos and internet, local is intranet, though I do much prefer the Cosmos light and local is heavy. Both are good. But obviously this is, I guess, the Cosmo local within the Cosmo, if we're being fractal. And this is more, a little bit about the ChairBot. So this is, I'll finish up this talk. Thank you all for attending with a little preview of the little friend full of joy that we're going to be making on Friday. And so this one this is the baseline model we're going to be working on, and then the top part of this one is going to be instead of pot, where it'll be growing. And so there's the Raspberry Pi, and we'll be teaching how to use Raspberry Pis, and then how to do RPC calls with the Raspberry Pis to have that Raspberry Pi do kind of really basic robotics. So the ETHbot over there is an inspiration for this Friday's ChairBot because it's growing plants off of it. So all these bipedal robots out there, it's all in vogue, but how many of them are growing plants off of themselves? So we're the first, I think, solar punk. Okay, that's it, everyone. I'm happy to stay and answer questions. Hopefully some of you are into writing that Viper code tomorrow and rolling up your sleeves. That's it.